everyone. Okay. In our last lecture, we have discussed about periodic table. Okay. We have discussed all the histories of the periodic table. First of all, Dobenia's triad. We have seen the Dobenia's triad and its failure. Then Newland's law of octave and its failure. Then come Mendeleev's and its failure. Okay. And what we have seen that all these Dobenia's, Newland's, and Mendeleev's. Okay, they have all given their periodic table. They have classified the elements on the basis of their atomic weight. Okay, and after that, Mosley has given his periodic table, which is named as modern periodic table. Okay, so we have seen that modern periodic table. It has some vertical columns and horizontal columns. Vertical groups and horizontal columns. Okay, total 18 vertical groups and 7 horizontal columns. Okay, vertical groups where is known as vertical groups are known as groups. Okay, there are altogether 18 groups and there are 7 periods. Okay, and see, we'll just a quick recap. Okay. क्या होगा पेज पेज हो गया जो so you have seen that there are 18 groups. Okay, the group you have seen that there are 18 groups. Group group first and second are S block. They are called S block elements. ठीक है? Group 13 to 18, they are known as the P block elements. Okay. And group 3 to 12. Okay. D block element. Okay. Understand? Group first and second, they are called S block elements. Group 13 and to 18, they are P block elements. And group 3 to 12 are D block elements. Okay. General configuration for S block element is what? General configuration for S block element is what is? NH 1 to 2. Okay. General configuration for P block elements. NH2 and P 1 to 6. Okay. For D block elements, it is NH2 N minus 1 D 1 to 10. Okay. So it means what? That those elements which has which has their last electrons in the S orbital, it comes in the S block element. And those when come the P orbital, it is P block elements. And those which have their last electrons in D subset, they are in D block elements. Okay. And what about the F block elements? F block elements are those elements which fall under the lanthanides and actinides. Okay, elements which are under lanthanides and actinides. Okay, till here it's clear. Okay. Now what we used to see here in the periodic table, it's named periodic. Okay. So there is a term periodicity. Periodicity. What is the periodicity? It is the repetition. Yeah, you can say repetition, gradual increase, gradual decrease in properties after a fixed interval. Okay. It is the repetition of properties. It either it be gradual increase or gradual decrease after a fixed interval of after a fixed interval. Okay. For example, we'll see the example of group 1. Okay. Hydrogen, lithium, sodium, potassium, rubidium, and cesium. Okay. These elements are of the group first. What we see that they have comparable properties. There some gradual increase or maybe the gradual decrease in their properties. Okay. So what is the cause of their periodicity? Okay. What may be the cause? What may be the cause of the periodicity? Okay. Cause lies under their configuration, electronic configuration. We'll see the electronic configuration of these elements one by one. The electronic configuration of hydrogen is 1s1. Okay, lithium is 1s2, 2s1. Sodium 1s2, 2s2, 2p6, and 3s1. Correct? About potassium 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. Correct? And so on. So what we are noticing here that all the last electron, okay, all the last electron lies here in the S subshell. All the last electron is S1. S1. And what this show about 1, 2, this one period. So the period. First period, second period, this is third, this is fourth period, and so on. So what is the cause of the periodicity is that the last electron is S1. So similar electronic configuration causes the periodicity. Okay, this is the cause of the periodicity. So now we'll discuss about the periodic trends. Periodic trends. Okay, in periodic table. So last time we have seen what we have seen a few periodic trends like atomic radius. Okay, we have discussed about atomic radius. Atomic radius. Okay, what what is the trend in atomic radius? As we go down, in a group, okay, the atomic radius increases. It increases. It increases. Okay, why it increases? Because the shell number of shell goes on increasing. Okay, and as we go from left to right in a period, atomic radius decreases. Okay, why? Because the nuclear charge increases. Okay, so we have discussed about atomic radius. Then what we have seen? Ionization enthalpy. Ionization enthalpy. it is also known as ionization energy. Okay. What was it? What is it? It is the energy required to remove the last electron or to remove the loose electron. Okay. So here also what we have seen that ionization energy, ionization energy is directly proportional to the nuclear charge. Okay. Ionization energy is directly proportional to nuclear charge. Okay. And ionization energy is inversely proportional to the size. Okay. Atomic size. So what we concluded by this, that as we go down from top to bottom, okay, as we go from top to bottom, ionization energy decreases. Okay, ionization energy decreases. And as we go from left to right, yeah, as we go from left to right, ionization energy increases. Clear? Yes. Yeah. Why it is going on increases? Because the nuclear charge is going on increasing. Okay, and because nuclear charge is increasing, the energy required to remove the last electron is increased. Means that we need a more amount of energy to remove the electron. There is uh, more attraction between the last electron and the nucleus. That's why the more amount of energy is required. That's why ionization energy is gradually increasing as we go from left to right. And from top to bottom, what happens? The atomic size increases. And as the atomic size increases, the removal of the electron becomes easier. So the lesser amount of energy is required to remove the loose electron. Yes. Okay. So we have discussed till here. There are some importance of knowing the ionization energy. Okay? Low ionization energies elements are reducing agents, basic in nature, create cations, form ionic compounds, and have the greatest photoelectric effect. Okay. What is the meaning of this? Low ionization energies elements. The elements which have low ionization energy are reducing agent. Yes. Basic in nature. Understand? Are you getting my point? Yes. Means what? Alkali, which have the lower ionization energies. It is the elements which come under the group first and second. Okay. So they are as a reducing agent. Yes. Reducing agent are those species, okay, are those species which oxidized itself and help to reduce others. Understand? What are reducing agent? Are those species which oxidize itself and helps to reduce the others. So if the ionization energy is less, okay, then what it will do? It can lose electrons. And that electrons will be used by the other species and it will reduce. Are you getting me? So those elements which have lower ionization energy, they are able to lose their electrons easily and are oxidized itself and help to reduce other. So they act as a reducing agent. Okay, they are basic in nature. So group first element, group second, group third elements are basic in nature. Okay. They create cations, obviously, if they are able to lose the electrons. They are forming the positive charge ions, that is cations. For example, sodium. Okay? It can easily lose one electron, and what it becomes? Na plus. This is the cation. Okay? And this, they form ionic compounds. Okay? Because ionic compounds are those compounds which are formed by the sheer transfer of electrons. By the transfer of electrons means one element should give electron and the other element accept electron. So giving electron is this sodium. So those elements which are having ionization energy lower, what are they? They are a good reducing agent. Yeah? They are basic in nature. They create cations and thus forming the ionic compounds. Okay. Now we'll see one example. This is potassium. Okay. And this is cesium. Which will have uh, more ionization energy here. More ionization energy. We'll give an example of two, which will have a more ionization energy. Ionization energy goes on increases as we go from top to bottom. So this is the cesium. This is in the bottom. So the more ionization energy will be of cesium. Okay? Now, after ionization energy, next is the electron in affinity and electronegativity. Okay, there are two terms: electronegativity and electron affinity. Actually, what happens? There, but children actually confused with these two terms: electronegativity and electron affinity. Okay, there are a little difference between these two words: electronegativity and electron affinity. Okay, let's clear first. Let's clear its difference. Okay, then we will study its strength. First, we'll clear about what is the difference in the electronegativity and electron affinity. Both have one very basic difference, and the most important difference is that electronegativity, there are those which accept electron. Okay? The tendency to accept electron. And electron affinity is the tendency to attract electron. Are you getting my point? Yes. This is the basic difference between the two: electron affinity and electron negativity. Okay. So electronegativity is the tendency to accept electron, and it is a tendency to attract electron. Understand? Okay, let's clear it with one example. We'll take an example of chloride. Okay, chloride ion. And this is the chloride ion. Okay. So electronegativity of chloride ion, any electronegativity of chlorine is maximum, and electron affinity of fluorine is maximum. How's that? Can you guess why this happened? The electronegativity of chlorine is maximum, but electron affinity of fluorine is maximum. See, the size of the fluorine is very small. Okay, so the size is so small. It's the size of the fluorine is very small. So it can attract the electron. It can attract electron, but it cannot accept it. Understand? Yes. Because there may be a repulsion because the size is very small. So there it may be a repulsion between the nucleus and the electron. So it can attract it is had the tendency to attract electron. It is the most electronegative element. Sorry, most electron affinity, but it cannot accept electron. And this chlorine is bigger than fluorine, so it can accept electron. Understand? Yes. Are you getting my point? Okay. Next, it is seen in isolated atom. Okay, and it is in the covalent bond. No, it's just opposite. Electron affinity is seen in the isolated atom and electronegativity in the covalent bond. Okay. Now we will see the factors on electronegativity. Electron affinity, or you can say enthalpy. No, we'll see first the definition of the electron. So we have seen the electronegativity and electron affinity. Now what is electron affinity? The amount of energy released when a neutral isolated gaseous atom receives an electron. Okay? As what we have seen right now, what is electron affinity? It is the energy released when a neutral isolated gaseous atom receives an electron. Okay? The amount of energy released when an isolated gaseous atom received an electron. So, if M is an element, if it attracts, if it gains one electron, so what it will become? M1. Okay, M negative anion and E1. Okay, E1 is what? E1 is the first electron gain enthalpy. Okay, and now what? M1, when it accepts other electron, it will becomes M minus 2 plus E2. Okay? E2 is the second electron gain enthalpy. Now when M minus 2 will gain one electron, it will become what? M minus 3. And it will is no E3. E3 is the third electron gain enthalpy. Okay. Now what is the fact to remember here is E1 is greater than E2 is greater than E3. Okay? The value of what we have seen here, the value of electron affinity decreases as the addition of electrons becomes more and more difficult and possible only by the absorbing some part of energy. Okay. Yes. So E2 becomes endothermic in comparison to E1. Okay. Means what? The electron gain enthalpies goes on decreasing as the addition of electrons becomes more and more difficult. Okay. Now we will see its trend. We will see its trend. So what is a trend in periodic table? Electron affinity. is inversely proportional to its atomic size. Okay. Electron affinity is inversely proportional to the atomic size. Okay. As the atomic size increases, electron affinity decreases. Second is what? Electron affinity is directly proportional to the effective nuclear charge. That's why in a period, as we move from left to right in a okay, in a period, as we move from left to right, electron affinity increases. Okay, as the effective nuclear charge, that is Z E. Okay, what is this? This is effective nuclear charge. So as we go from left to right in a period, okay, the effective nuclear charge increases. So the electron affinity also increases. Okay. So what we can say, the electron affinity follows the following series. Can you say the series? So which is the most electronegative elements? Halogens. Because halogens comes under the group 17. Okay. The most electronegative elements are halogens. Then oxygen family. Okay. Then carbon family and so on. Okay. Just an example. So as we move from left to right, the electron affinity increases. Why? Because the effective nuclear charge goes on increasing from left to right. So their electron affinity is increases. And what is electron affinity? What is electron? The amount of energy released when an electron is added. Okay, to a neutral atom. Okay. Now we'll see in group. Okay. In a group, what we have seen here, electron affinity is inversely proportional to the atomic size. And what happens in a group? Atomic size goes on increasing. So in a group, moving down from top to bottom, the electron affinity will decreases because atomic size increases. Okay. So in a group, okay, as we move down from top to bottom, okay, say, electron affinity increases. Decreases because atomic size increases. Okay, we have seen electron affinity is inversely proportional to the atomic size. Okay, now you see some fact. The sequence of electron affinity of group 7 is as follows. Okay, if we will see the sequence of electronegativity, sorry, electron affinity in halogen groups, what we will observe that the most element which has more electron affinity is what? Fluorine. Then fluorine. Okay. It should be like this. Then bromine, then iodine. Right? But it is not like this. Okay. The electron affinity of chlorine is more than the fluorine. Why so? But this is not as it is. What we have seen, the chlorine is more electron affinity than fluorine. Why?
Because chlorine has small size and
Because of the size.
Mm.
Okay.
Yes.
Because fluorine is smaller in size, it's very small size, so it cannot accept
Accept
electron.
electrons.
Okay.
Also,
So, and now we'll discuss about electronegativity. Electronegativity. Mhm. So, what we have discussed right now, that electron affinity and electronegativity. Okay. Electron affinity is the to accept the electron, and electronegativity is the to attract the electron.
yes.
Okay.
Mm.
So what is the electronegativity? It is the ability or tendency of an atom to attract the shared pair of electrons.
Mm.
Okay, I want to clear it. I want to make it again clear that electron affinity and electronegativity. Okay, electron affinity is the to accept the electron, and electron affinity. So electron affinity to accept electron, and electronegativity is the tendency to attract the electron. Okay.
Mm.
The ability or tendency of an atom in a molecule, okay, to attract the shared pair of electrons. Okay. So electronegativity is the ability or tendency of an atom in a molecule to attract the shared pair of electrons.
Mm.
Okay. Now we'll see the factors affecting the electronegativity. Factors affecting electronegativity. Okay. On the size of atom, on size of atom. Okay. Electronegativity is inversely proportional to the size. Same thing as the electron affinity. Okay. Electronegativity is inversely proportional to the size. As the size increases, its electronegativity decreases. And what? On nuclear charge, okay, electronegativity is directly proportional to the nuclear charge. Same thing. Okay? So as the nuclear charge increases, electronegativity increases. Now, on charge on cations. Charge on cations. Okay? What we see here, the charge, okay, Fe2 plus and Fe3 plus, which will have more electronegativity. The Fe3 plus will have more electronegativity. Okay? Because the more positive charge, it means what? It can attract more electrons. Okay? And it is a reverse case with anions. Charge on anion. Okay? Means if we'll see the anion like n minus 1, minus 2, and minus 3. The reverse case means it will be like this. Electronegativity decreases as the anion charges on the anion increases. Okay, because of what? Because is the more charge on anion, it can attract less electrons. Can attract less electrons. So what we have seen that a cation is more electronegative, okay,
Yes.
than its parents atom. Okay, why? Because cation can attract more electrons. So the a cation is more electronegative than its parent atom. Means what? For example, if we'll take an example of Fe and Fe2 plus, which is more electronegative? Fe2 plus. Okay, and in Fe2 plus and Fe3 plus, which is more electronegative? Fe3 plus. And also one thing, electronegativity is directly proportional to the S percentage. S percentage means what? In here it comes hybridization. Hybridization, you know, Sp, Sp2, Sp3. Okay? So therefore, the electronegativity follows the order of this Sp, Sp2, and Sp3. Means what? Electronegativity is directly proportional to the S percentage. So S percentage is going on decreasing, so the electronegativity goes on decreasing. The most electronegative is Sp, then Sp2, then Sp3. Okay. So how we can see this? We can take an example. We can see with this example. This is C triple bond C. Okay. C double bond C and C single bond C. This is what? This is Sp. This is most electronegative. Okay. This is Sp2, then Sp3. Okay. So which is the most electronegative here? This one. Triple bond C. So these are the factors, okay, affecting electronegativity. Atom size of atom, electronegativity depends upon the size of atom. Okay, it is inversely proportional to the atomic size. Okay, electronegativity is directly proportional to nuclear charge. Okay, and cations, as the charge on cations increases, electronegativity increases. Okay, but in anion it is just reverse. A cation is more electronegative than its parent atom from which it is formed. Electronegativity is directly proportional to the S percentage. Hence was Sp is more electronegative than Sp2 than Sp3. Okay? Now we'll see its variation in period. Okay? In a period, moving from left to right, what we'll see? Moving from left to right. Left to right. Okay? Electronegativity increases. Okay? Why? Because the effective nuclear charge increases. So as we go from left to right, electronegativity increases. And as we go from, okay, you'll see lithium. Okay, lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. So as we go from left to right, okay, its electronegativity goes on increasing. Okay. So halogens are the highest electronegative elements in a period.
Mm.
Okay.
Yes.
Whereas the alkalis are the lowest electronegative elements. Okay. Halogens are the highest electronegativity, highest,
Mm.
and alkalis are the lowest. Okay. And what about the alkali electronegativity of group 0 element? Electronegativity of a 0 group. 0 group are what?
No.
Noble gases. Okay. So what is the electronegativity of 0 group elements? Is 0.
Mm.
Okay. It's 0 because they have no tendency to attract electrons due to their stable octet state. Okay. Because of their stable configuration, they cannot attract electrons, though, so their electronegativity is 0. No, in group. Okay. In a group, moving from top to bottom, what happens? As we go from, as we go from top to bottom, what will happen?
This will increase and
Therefore, size, atomic size will increase. Therefore, electronegativity will
de-
decrease. Okay. Electronegativity decreases. Now, we have discussed all the periodic trends. Yes. What we have discussed:
this
atomic radius,
ionization
and
enthalpy,
ionization enthalpies,
electronegativity,
electronegativity,
electroactivity,
electron gain enthalpy. Okay. And yeah, one more thing: metallic character and non-metallic character. Okay. Other thing is metallic character. Metallic character. So what will happen in the metallic character as we move from left to right, or we go from top to bottom? Okay. The metallic nature is what? Metallic nature is electropositive nature. Okay. Metallic nature means electropositive nature. So it decreases from left to right. Okay. And increases from top to bottom. So metallic nature, electropositive nature, reducing nature, basic nature, radius or ionic mobility decreases from left to right. Okay, I will write right here. Metallic character, yeah, metallic nature. Okay, electropositive nature, okay. Reducing nature, basic nature. Okay. Decreases as we move from left to right. Okay, understand? Metallic character goes on decreases as we move from left to right. Okay, and increases from top to bottom. Okay, so which is the most which element will have the most metallic character?
uh, first row.
Yeah. Group first element sodium. For example, sodium. Okay. And as we move from sodium to as we move from sodium to magnesium to aluminum and all in period, okay, its property, metallic nature goes on decreasing. Okay. And as we move from top to bottom, the metallic nature goes on increasing. Okay. Now, non-metallic character. What will happen with the non-metallic character? Non-metallic character means non-metallic character, electronegative nature, oxidizing nature, and okay, these goes on increases. Okay, this goes on increases from left to right. Okay, and decreases from top to bottom.
Bottom.
Now we are able to understand all the trends. Okay. Now in short, we'll see in an periodic table. Okay, summary. We can see its summary like that. Summary. Suppose, suppose this is our periodic table. In just in roughly we can draw like this, right? Okay. Roughly we can draw our periodic table like this. Fine. These are the group S block elements,
Mm.
P block
P block.
elements. These are S block elements. These are P block elements. Okay.
Yes.
D block
D block.
and the below they are F blocks. Okay. Just we roughly can see. So what happens here? Atomic size. We will see the atomic size increases. Atomic size increases. Okay. Electron affinity increases from going left to right. Okay. And on going down top to bottom, what happens? And we will see like this. So from top to bottom, okay,
Mm.
electronegativity decreases. Okay, means it will not increase like this, it will increase like this. Okay, non-metallic character increases here. Okay, this is the like summary. Electron affinity goes on increasing from. It's not a good drawing. Electron affinity goes on increases from left to right. Atomic size goes on increases from top to bottom. Electronegativity goes on increases from goes on decreases from top to bottom. Okay. So till now we have done all these periodic trends. Clear? Okay. Now we'll see the nature of oxides and hydroxides. Okay. Nature of oxides and hydroxides. We'll see the nature of oxides. As moving from left to right, okay, basic nature decreases and acidic nature increases. Okay, moving from left to right. Okay, what happens? Basic nature decreases and acidic nature increases. Okay, let's take an example. Hmm. Okay, it means what? That the oxides of metals. Because the left side are the metal oxides and right sides are the non-metal oxides. Okay, the metal oxides are basic in nature. Non-metal oxides are acidic in nature. Okay. For example, we'll take take example Na2O. Okay, sodium oxide MgO, Al2O3, SiO2. Okay, and so on, and SO2 and Cl2O3. Okay. So what we are going to discuss here, that on moving from left to right, okay, their basic nature goes on decreasing. Means what? These okay, these oxides means oxides and just we have discussed that metallic character goes on decreasing, right now metallic character goes on decreasing from left to right. So these are the metal oxides and these are the non-metal oxides. So we can say like this, like that, okay, metal oxides are more basic. They are basic in nature. And non-metal oxides are acidic in nature. Okay. So oxides of metals are basic. Okay. And on moving downward, what will happen? On moving downwards. Okay. On moving downwards, basic nature increases. Okay. Basic nature increases. So for example, in group first A, okay, CS2O is more acidic. CS2O is more basic than Na2O, MgO. Okay. So CS2O and PSOH, okay, are most basic. Okay. Understand? They are the most basic because they are in the bottom of the group. So see, what we have discussed here, that the basic character goes on decreasing. Okay, means metal oxides are basic, non-metal oxides are acidic. So sulfur dioxide and sulfur dioxide, carbon dioxide, these are which type of oxides? which type?
Yes. Acidic.
Sulfur dioxide, carbon dioxide, they are acidic in
Acidic.
nature. Okay?
Yes.
Sodium oxide, magnesium oxide, they are basic in nature. You can test it with litmus paper. Okay? The identification indicators which identify the acid and base, we can test by litmus paper. Okay, we can we can do an experiment to test whether carbon dioxide is acidic or basic. Okay, by burning we'll burn coal. Okay, and what we'll do on the flame, on on the fume of the coal, we'll take one moist litmus paper. Okay, one moist litmus paper, blue litmus paper. So what it will become? It will become red. We know that the in acid the blue litmus paper changes to red, and in base red litmus paper changes to blue. So we can test whether carbon dioxide gases or like that gases are acidic or not by using one litmus paper. Okay.
Mm.
The same way we have discussed. Lecture है इतना 9 बजे आपका okay आपका 9 बजे तक ही रहता है so I hope you are clear. Everything is clear. Okay. The trend. So one thing, just one thing we should discuss discuss that there is a diagonal relationship. One last thing. One last thing is that there is diagonal relationship. Diagonal relationship means what? Several periods components are compared. Several period second components are comparable to period third ones. Okay, that are diagonals into them. Means there is a diagonal relationship between the properties. Okay, so period second components are comparable to period third components. Okay, so just we'll take one example. This is the first A, second A period, third A, and fourth A. Okay, lithium, sodium. Here it's the beryllium, magnesium, boron, aluminum, carbon, and silicon. So what we see that the properties of lithium and magnesium are comparable. Beryllium and aluminum are comparable. Okay, boron and silicon are comparable. So diagonal relationship is not observed after group fourth. Okay, diagonal relationship is observed only up to group fourth.
Yes.
Okay, though after group fourth, the diagonal relationship is not observed. Okay. For example, Li2, CO3 and MgCO3. Okay, both exhibit diagonal relationship where on heating they form their oxides and carbon dioxides. Okay,
Yes.
lithium, this lithium carbonate and magnesium carbonate. Okay, both are showing the diagonal relationship. Okay, what happens on heating? Both of them they will give out oxides and carbon dioxides like Li2CO3. Okay,
Mhm.
heating. And when we heat magnesium carbonate, what happens? In both of the cases, they will give okay, both exhibit diagonal relationship. How? On heating, they form their oxides and carbon dioxides. Okay? Okay, done. So, stop कैसे कर रहे हैं? Stop.
I have to sprint.
Stop.